For this particular problem, we are interested in the calculation of load resistance for the maximum power transfer. First, we are converting this given network into the Thevenin's equivalent network. So here, what is my aim? My aim is the calculation of the two things, because we have to find out the VTH and we have to find out the RTH. But whenever we have the dependent sources, in that particular case, this RTH is given by the formula, this VOC divided by ISC. And this VOC is nothing but it is same as the VTH. That's why first we will find out the VOC or VTH, which is nothing but we will remove the load resistance and we will redraw the same circuit and we will calculate its value. I will write the similar things. Removing the load resistance and redrawing the same circuit, we get here removing load resistance and redrawing the same circuit. Redrawing the same circuit. And here I will draw this particular figure. It will be something like this. This is the current. Here it is the 5 ohm resistance. This potential, this is the current source, and here will be the terminal A. This is the terminal A, and finally we have this terminal as the B terminal. And in this case, this value is Vx divided by 4. This value is the 5 ohm. Here is this current, which is of the 10 amperes. This is 3 ohm, and it is again plus and minus. This value is the Vx. Here, this is the 3 ohm resistance. Is it right? Here we are interested in the calculation of this VOC, terminal voltage. But here, in this case, this dependent source is a Vx. Whenever we have this load resistance and whenever we have removed this load resistance, I will name this as a Vx1. This is Vx1, then this will become Vx1. At the same time, we are not able to use the mesh analysis here because we are not in a position to apply the KVL to this loop or this loop due to the presence of two current sources. That's why we have to use another methodology. Here, I will use the nodal analysis method. This is one node and this is other node. This is one branch, second branch, third branch. Now here, in this case, I will give some name other than Vx, Va and Vb. That's why I will give some name to this node as node P, and its potential will be the Vp. Its potential will be Vp. Yes. Its potential will be Vp. Its potential will be Vp. Just I have started for the late comers. I will just explain the things, because I am starting this problem once again to begin with from the initial scratch. Now here in this case, this is Vp and this is the ground node in that particular case. Now here this current will be the I1, and in this case this current will be the I2, and finally I will assume this current downward, because look at the polarity. This polarity suits for downward current. That's why this branch current, this is Vx1, this branch current, I have taken it as I3. Now we will apply the KCL and we will find out its equation. I will write here, applying KCL at node P. We will apply the KCL at node P and we will find out its equation. How is the equation? Incoming current is equal to outgoing current. This is incoming, this is incoming. This equation in this particular case is, this is I1 plus I2, which is equal to I3 is the equation. Is it right? So here in this case already we are aware of this current I1, which is 10 ampere, plus I2 is this current. Whatever it may be in series with this, the current will be the same, which is Vx1 divided by 4. This is Vx1 divided by 4 is its current in this branch, which is equal to I3, and I3 is the current in this branch. How is the equation? This is Vp minus 0 divided by resistance, means its equation will be Vp divided by 6 is the equation. Now we will simplify this equation and we will name this equation as equation number 1. Here it will be 10 plus this value Vx1 divided by 4, is it right, which is equal to Vp upon 6. Otherwise, what I will do, I will shift this value to the next side. In this case, it will be Vp divided by 6 minus this value, which is Vx1 divided by 4. It is Vx1 divided by 4. And if we are simplifying this equation and if we are calculating its values, this is 1 upon 6. I will find out this value. It is 1 divided by 6. Its value will be 0.166. Means 0.166 is the value of the Vp. This is Vp. Just I am finding this fraction. Minus 1 upon 4. This is 1 divided by 4. Its value will be, it is minus 0.25. This is minus 0.25 Vx1. This is 0.25 Vx1. This value I have simplified, which is equal to 10, and this is the equation number 1. Now we have the one equation and two unknowns. What are the unknowns? Unknown is Vp and Vx1. In what value we are interested? We are interested in the calculation of this current I2 and I3. For that purpose, we have to find out this value of the Vx1 as well as we have to find out this value of the potential Vp. Means here we have this equation, but another equation we want in terms of Vp, in terms of Vx1, or Vx1 in terms of Vp. So I will find out the Vp. Now calculating Vp in terms of Vx, we get. Here we are interested in the calculation of Vp in terms of Vx, means I will find out the Vp directly. This Vp is equal to. Here we are interested in this potential, means we can use this path because we are not in a position to use this path and this path, because here is a current source, we don't know the voltage across current source, and again this is also current source, we don't know the voltage across the current source. That's why I will use this path. If we are traveling in this direction, otherwise here this current also, this is plus and minus, this is polarity because it is downward. If we are traveling upward, negative to positive, that is a plus. This is plus. How much is this potential? That is Vx1. And negative to positive, which is a plus. How much is the voltage across this? Voltage across that will be 3 into its current, and its current is I3. 3 into I3. Now I will simplify this equation and I will name this equation as equation number 2. Look at here. I have interpreted I have placed the value Vp Vx1. I will put the Vp first. This is Vp. Then I will shift this Vx1 on the next side, that is Vx1, that is minus Vx1. Then it is minus 3 into I3, and which is equal to 0. This is the equation number 2. Now what we have the two equations and three unknowns. Because one unknown is a Vp, another unknown is a Vx1, and third unknown is now introduced, which is I3. Means I am interested to calculate the I3 in terms of Vp or Vx1. Now, calculating I3 in terms of Vp and Vx1. But already we have calculated the value of I3 in terms of Vp, which is this. Therefore, this I3 is equal to Vp divided by 6. Is it right? It is Vp divided by 6. I will simplify this equation, means it will be 6 into I3, which is equal to Vp. Or I will shift this value to the next side. It's Vp minus 6I3, which is equal to 0. This is the equation number 3. You can use any calculation method, no issues. In the last case, what I have done, in the last case, whenever I have solved a similar problem, in that particular case, I have placed this value of I3 in this particular case, and we have the two equations. But here, I am arranging the equation in terms of Vp Vx1. This is Vp Vx1 I3. This is Vp and I3, which is equal to 0. Now here, we are interested in the calculation of the parameters. We will find out the Vp, then we will find out the Vx1, and then we will find out the I3. And then we are in a position to find out its value of the VTH, or which is the VOC. Now I will use the calculator. I will shift this mode of this calculator, and I'm going into this equation mode. And we have how many unknowns? 3 unknowns. What are the values of the first term? The values related to the first terms are that is if I am going to that three equations, value of the A1 which is 0.166. 0.166 is the first value. How is the second value? This value is minus 0.25. This it is minus 0.25. Is it right? What is the third value? Third value is I3. How much is the value of I3? 0. The next, how much is the value of the constant? The 10. This constant is the 10. Is it right? Then again, this Vp is 1. Then this Vx1, it is minus 1. Then next I3 is, this is minus 3, which is equal to, and this constant is 0. This constant is 0. Now I will substitute the value of the Vp again here, which is 1. This is Vp is 1. Then we have the value of Vx1, which is 0. And how much is the value of I3? It is minus 6. This value is the minus 6. Is it right? What is the next? D3, its value it will be 0. This value is 0. Means I will put its value as 0, which is equal to. Now here in this case, this Vp is found to be 243.9 volt. Someone has unmuted himself. Please request to mute yourself. Yeah. Because unnecessarily there are some issues. Okay, fine. So here in this case, this is value of Vp. How much is the Vx1? Vx1 is, it is 121.95. And how much is the I3, which is 40.65? This is 40.65. Is it right? Here in this particular case, if we have calculated these values, value of the 200 Vx1, it is, these are the values. Here, all of you check the calculations once again. I will check this calculation once again. This value is A1 is this 0.166. This is minus 0.25. Third value is 0. The next is constant is 10. Then for equation number 2, this is A2 is 1. Then it is minus 1. Then it is minus 3. The constant is 0. Then for third equation, Vp is 1. This A3 is 1, then this value is 0, the next value is minus 6, the next value is 0, which is constant. In that case, we are able to get the values. These are the values. Check the previous calculation. If there is a mistake, there may be the calculation mistake. Otherwise, these are the values which are correct, I guess. This is the value VOC, or which is same as the VTH, which is equal to, it is a modulus of. Is it right? Now here in which value we are interested? I3 we have calculated. I2 means first we need to, before this calculation of this VOC or VTH, we need to calculate the value of I2. First I will calculate that value of I2. What is the formula for I2? Here I2 is nothing but Vx1 divided by 4. This value is Vx1 divided by 4 is this value. How much is the Vx1? Vx1 already we have calculated, which is 121.95 divided by 4. Calculate this I2. If I am calculating this I2, it is 121.95 divided by 4. If I am calculating this value, 30.48 is the value of I2. 30.48 amperes is the value of I2. Now, if we know everything, then we are in a position to find out the value of the VTH, which is equal to the modulus of. We are traveling from the B towards E. We are traveling from negative to positive, which is a plus. What is the first value? First value is the Vx. How much is the Vx, which Vx1? We have calculated this Vx1 as 121.95 is the value of Vx1. Then again, negative to positive, which is a plus. Its resistance is a 3 and into its current, and its current is I3, and the value of the I3 is 40.65. This is 40.65. Is it right? And finally, this is the direction of the current, means it will be the plus, and this is the minus, if we are traveling from the negative to positive, which is a plus, and the phi into its current, which is I2, this phi into it is 30.48 is the value. And if we are simplifying everything, then we are able to calculate this value. I will do the calculation first. This is 3 into 40.65. This value is 121.95 plus this is 121.95 again. This is 121.95, and the value of the last term is this is 5 into this is 30.48. This value is 152. Means it is plus, it is 121.95 plus it is It is 121.95. If we are doing all this calculation, its value, it is found to be 396.3 volt is the value of the VTH. Is it right? 396.48 is the value of the VTH. And if we know the value of the VTH, then we are in a position to find out its value of the RTH. Up to this, I have taken in the last lecture, but there may be some calculation. That's why I have started freshly here. In this case, I will come back to you and I will check the answers and then we will proceed further. Yes, Saurabh?
Yes, sir.
Whether these calculations are correct, whatever I have done?
Yes, sir. Correct.
Yeah. Now here I will proceed further. If we know the value of the VTH or VOC, next we are interested in the calculation of the ISC. For that case, what we will do, we will remove this load resistance and we will short circuit the output terminals. I will use the similar philosophy here. I will use the similar philosophy here and I will work out on that. Here, in this case, now we are interested in the calculation of the ISC. I will write the same. For the calculation of RTH, which is equal to VOC upon ISC, that is ISC, because VOC already we have calculated. We will remove load resistance and short output terminals. We will short output terminals. Is it right? Now, how will be the figure for this case? If we are going to this, its figure will be something like this. I will redraw the same figure. Now look at how will be the figure. This will be the figure. It is the 5 ohm. This value is Vx divided by 4. This is Vx divided by 4. Sorry, we have removed the load resistance. This will be the short circuit. This is the short circuit. Is it right? And here, this is the 10 amperes. This is the 10 amperes. It is 3 ohm. This is plus and minus. This value is Vx and it is the 3 ohm. The circuit will be something like this. Is it right? So here in this case we are interested in the calculation of current in this branch. We are interested in the calculation of current in this branch, which is the short circuit. Now here in this case, be careful about this particular problem because it is a little heavier. In this case, we are not able to use the nodal analysis method. Otherwise, if it is a resistance, then we might have calculated its parallel combination. But here in this case, we cannot find out its parallel combination and we cannot make this branch as a 0 because here is a current source. That's why, and another case is that we have this branch as a 0 resistance branch. That's why we are not able to use the nodal analysis because we are not able to calculate the current in this branch. That's why we have to use the mesh analysis. How will be the mesh analysis? Now look at, this is loop 1, this is loop 2, loop 3. We are able to apply the KVL to the super mesh. Then from this current source branch, we can find out the second equation. From this current source branch, we can find out the third equation. Is it right? In that way. Is it right? Now here, but while assuming the current to this loop, try to assume the current which is suiting to this polarity. That's why I'm assuming its current is something like this. This current may be I will give some another names, that is I1 dash, because I1, I2, I3 I have assumed in the previous case also. This current may be clockwise or may be anti-clockwise, that is I2 dash, and this current may be the third current, which is I3 dash is the third current. And our aim is the calculation of current in the short circuit, which we are interested in the calculation of I3 dash. Be careful here. We cannot use the nodal analysis method here. And in this case, in case of the calculation of the VOC, we cannot use the mesh analysis because here we cannot apply the KVL to this loop or this loop. That's why here mandatory we have to use the nodal analysis or any other method other than the mesh analysis. And in this case, we are not able to use the nodal analysis. We have to use another method for this calculation. Is it right? We have to use the nodal analysis method for this calculation. Just wait, I'm coming back. Yeah. So here in this case, we are using this method. Now I will mark the polarities. This is plus and this is minus. Already it is marked. For this case, it is plus and minus, and that's it. Now we will apply the KVL to the first loop and we will start from this point. We will start in the clockwise direction. We will start in the clockwise direction, that is for super mesh. That is the first applying KVL to super mesh. Super mesh. If we are applying the KVL to the super mesh, how will be the mesh? We will travel in this direction, clockwise direction. Negative to positive, that is a plus. How much is the potential? This potential is a 3 into I1 dash. Then negative to positive, which is a plus again, 3 into again I1 dash. Then positive to negative, which is minus 5 into I2 dash. And after that, there is no element in the circuit which is equal to 0. This is the equation. Now here, if I am simplifying this equation, how will be the equation? In this case, equation will be 6 I1 dash. This will be 6 I1 dash. This is 3 plus 3, that is 6 I1 dash minus 5 I2 dash, which is equal to 0, and this is the equation number 1. Now we have the one equation from the super mesh. Whatever it may be this direction, maybe clockwise or maybe anti-clockwise, we can travel in the clockwise or we can travel in the anti-clockwise, that is the philosophy. Now here I will write from 10 ampere current source branch, we get. What we get from the current source branch? We get here this 10 ampere is upward. This 10 is equal to. Now look at which currents are upward. This I1 is also upward and this I2 is also upward. Means here in this case I1 dash plus I2 dash is the equation. If I am simplifying this equation will be I1 dash plus I2 dash, which is equal to 10, and this is the equation number 2. This is the equation number 2. Is it right? And finally, we can find out the value of the I3 dash directly from loop 3. We get. What we get from the loop number 3? How is the value of this I3 or from this current source branch? If we are referring this current source branch or loop 3, what we will get? This current is upward. How much is the value? This is Vx divided by 4. Is it right? This is Vx divided by 4. This is upward, which is same as this current is upward, which is I3 dash minus this current, that is I2 dash. To be exact, in place of loop 3, what I will write? From Vx by 4 current source branch. Current source branch. We get this equation. If I am simplifying this equation, now look at how is the equation. This equation will be minus I2 dash plus I3 dash, which is equal to 0.25 Vx. Is it right? This is the equation number 3. Now look at how many equations we have and how many unknowns we have. We have one unknown second, this is 1, 2, and this is 1, 2, and 3. Means we have the 4 unknowns. One is I1, second is I2 dash, I1 dash, I2 dash, I3 dash, and Vx. Means again we have to find out the relation between Vx and other parameters. maybe I1, maybe I2, and so on. Now I will find out, we will calculate Vx in terms of maybe I1 dash, or maybe I2 dash, or maybe in terms of I3 dash, or maybe combination of all, or combination. Is it right? Or combination. Now how I will do? I will find out the Vx, which is equal to, just I am interested in this potential Vx. This potential में हमारा interest है. How much is this value? This value is 3 into I1 dash. Is it right? Because voltage across this resistors, which is Vx, is nothing but 3 into its current, which is 3 into I1 dash. This is the equation number 4. Now we have the 4 equations and 3 unknowns. But our calculator does not support for 4 equations. That's why I will reduce one equation. I will substitute that value of the Vx from equation number 4 into equation number 3. I will modify the equation number 3, and then that will be the equation number 5, and I will use the equation number 1, 2, and 5 for that calculation. Now putting equation number 4 in equation 3. If we are doing that substitution, we get. Now look at what we get. In this case, if we are doing that substitution, this is minus I2 dash plus I3 dash, this value, which is equal to 0.25 into Vx, means it is 0.25 into Vx. And how much is the Vx? This Vx is 3 into I1 dash. 3 into I1 dash. Is it right? And if we are shifting this value to the next side, and in that case, its value will be, I will first find out the value of 3 into 0.25. This value is 0.75. This value is 0.75. Is on this side, that value will be the minus 0.75 I1 dash. Is it right? Then minus dash, and this constant is 0. Means here we are able to find out its values. The value of the first current, which is I1 dash, is 4.54. This is 4.54 amperes. Then I2 dash, its value is 5.45. This is 5.45 amperes is the value. And the third is, it is 8.86. It is 8.86 amperes is the value. And which is equal to 8.86 amperes is the current flowing through the short circuit path, which is nothing but the Norton's equivalent current. Is it right? It is same as the Norton's equivalent current. Right? I will come back to you. I will check the answers and then I will proceed further. Anyone has the answer with you? Chinmay Lakde, Van Chaya, anyone has the answer? Yes.
Yes, sir. Correct.
Correct. Okay, fine. Now here, if we know these values, then we will find out its RTH. This RTH is nothing but VOC upon ISC, which is equal to, how much is the value of the VOC which we have calculated? The value of the VOC which we have calculated in the second case is 396.3. This is 396.3 volt is the value of the VOC, divided by ISC is 8.86, which is equal to, if I am finding this value, I will use the calculator again. It is 396.3. This is divided by 8.86. If we are doing this calculation, sorry, I should come out of this mode. Then it is 396.3 divided by 8.86. If I am doing this calculation, 44.72. Is it right? 44.72 is the value of RTH. Now, if we know the VTH and RTH, then complicated network is replaced by the Thevenin's equivalent network. This will be the Thevenin's equivalent network, and then we will apply this theorem, which is 44.72 is this value. This is 44.72 ohm is the value of this RTH. It is the value of RTH. is the value of RTH, and its value of the VTH is 396.3. This is 396.3 volt is the value of the VTH, and we will reconnect the load resistance, which is RL. Is it right? But as per maximum power transfer theorem, what we have? This RL is equal to 44.72 ohm is the RL. If we know the RL, then we are interested in the calculation of the maximum power. For that purpose, first we have to find out its load current IL, which is 396.3 divided by 44.72 plus 44.72. First find out this value, which is equal to, what I will do? I will do this calculation, which is 396.3 divided by start bracket 44.72 plus 44.72. I will close the bracket. Just I did the mistake, I guess, here. Yeah. This is 0.72 plus 44.72. I will close the bracket, is equal to, this is 8.01 amperes. This is 8.01 amperes is the load current. I will check these answers from anyone. Anyone has the answer? Saurabh. Yes, correct. Correct.
4.43.
This value is 4.43.
Yes.
4.43
ये 4.43 है. I will check once again. This is 4.43 amperes. I will check once again. Here in this case, 396.3. This is 396.3, which is divided by start bracket. This is 44.72 plus 44.72 close the bracket is equal to. This is 4.43 amperes. Absolutely fine. This is 4.43 amperes is the load current. And if we know the load current, then I will write the last step here. How is the last step? That is P max is equal to maximum power which is transferred to the load is equal to IL square into RL, which is equal to, that is 4.43 its square into RL, which is 44.72, which is 44.72. Work out this calculation and tell me the final answer. Anyone?
64.34.
64.34 watt is the maximum power, that is P max, which is transferred to the load as per this particular theorem.